Welcome back to Medinare. In this video, let's discuss about microscopic features of gingiva. On microscopic examination, it is seen that gingiva has two parts. One is epithelium and connective tissue. Gingival epithelium is stratified squamous in nature and it is highly cellular. Connective tissue in the gingiva is less cellular and is primarily composed of collagen fibers and ground substance. So in this video, let's focus on the epithelium part, right? So as I said before, gingival epithelium consists of a continuous lining of stratified squamous epithelium, and there are three different areas on the gingival epithelium, such as outer or oral epithelium, sulcular epithelium, and junctional epithelium. It has got a function to be a physical barrier to infection and underlying gingival attachment. Not only that, but it also plays an active role in innate host defense by responding to bacteria in various ways, such as increased proliferation, alteration of cell signaling events, changes in differentiation and cell death, and ultimately alteration of tissue hemostasis. So basically, there are two types of cells in the gingival epithelium. One is keratinocytes and the other is non-keratinocytes. Keratinocyte is a principal cell type of gingival epithelium. It synthesizes keratin, and it constitutes about more than 90% of cell population. The keratinocytes are interconnected by structures on the cell periphery called as desmosomes. So we know that gingival epithelium has to protect the deep structures, and also it allows for a selective interchange with the oral environment. So this is happening by two processes called proliferation and differentiation of the keratinocytes. Proliferation of keratinocytes is nothing but the number of cells is going to get increased. It takes place in the basal layer and less frequently in the suprabasal layer. In this process, a small proportion of the cell remains as a proliferative compartment at the basal layer, while the remaining large number of cells begin to migrate to the surface. So in simple words, it is getting proliferated at the base and getting pushed or migrated to the upper layer. The next process is differentiation. This actually involves the process of keratinization. Here, progression of biochemical and morphologic events occur. The main morphological changes are progressive flattening of the cell with increasing prevalence of tonofilaments, the couple of intercellular junctions with production of keratohyalin granules, and disappearance of the nucleus. Now this is a very important viva question here. Surface keratinization types. There are basically three types of surface keratinization. They are orthokeratinization, parakeratinization, and non-keratinization. So there are basically only 3 points which is going to differentiate all these three types. In orthokeratinized layer, complete keratinization occurs so that orthokeratinized layer is formed. In this, the superficial layer will be a horny layer similar to that of all skin, and the stratum corneum has no nuclei and a well-defined stratum granulosum is present. And only some areas of the outer gingival epithelium are orthokeratinized. So what is different in parakeratinized layer? Here, keratinization process is an intermediate stage and the nuclei present in the stratum corneum are pycnotic in nature. Rather than giving rise to stratum granulosum, keratohyalin granules are found dispersed. And this type is the most prevalent surface area of the gingival epithelium. The third type is non-keratinization. And the name suggests it has no keratinization. It has neither stratum granulosum nor stratum corneum. But the superficial cells have viable nuclei. The keratin proteins are composed of different polypeptide subunits. The basal cells begin by synthesizing low molecular weight keratin and they express other high molecular weight keratin as they migrate to the surface. K1 keratin polypeptide is the main component of stratum corneum. Also, we have some other proteins like keratolinin, involucrin, and filaggrin. Keratolinin and involucrin are precursors of chemically resistant structure located below the cell membrane, and filaggrin have the precursor that are packed into keratohyalin granules. Now when a layer is getting transformed to a horny layer, the keratohyalin granules disappear and give rise to filaggrin. This forms the matrix of the most differentiated epithelial cell, which is called the corneocyte. Let's see what is Odland bodies. Odd-line bodies is also known as keratinosomes, and these are dense granules found on the uppermost cells of stratum spinosum. They contain an enzyme called acid phosphatase enzyme. And this enzyme destroys the organelle membranes which occur suddenly between stratum granulosum and corneum and during the intercellular cementation of cornified cells. And therefore, the acid phosphatase is an enzyme that is closely related to degree of keratinization. Moving on to non-keratinocytes. Melanocytes, Langerhans cells and Merkel cells are non-keratinocytes. Melanocytes. These are dendritic cells located in the basal layer and spinous layer of the gingival epithelium. They synthesize melanin in organelles called premelanosomes or melanosomes. These melanosomes have an enzyme called tyrosinase. This hydroxylates tyrosin to dihydroxyphenylalanine, which is otherwise known as DOPA. This in turn gets progressively converted to melanin. Melanin granules are phagocytosed and contained within other cells of the epithelium and connective tissue called as melanophages or melanophores. The next cell type is Langerhans cells. Langerhans cells are dendritic cells located among the keratinocytes at all suprabasal layers. They belong to mononuclear phagocyte system, otherwise known as reticuloendothelial system, as modified monocytes derived from the bone marrow. They contain elongated granules and they are considered as macrophages with possible antigenic properties, and they are known as antigen presenting cells for lymphocytes. They contain G-specific granules, also known as Birbeck granules, and they have marked adenosine triphosphate activity. They are usually found in oral epithelium of normal gingiva and absent from junctional epithelium of normal gingiva. The third type of non-keratinocyte is Merkel cell. They are located in deep layers of the epithelium and they have nerve endings, and they are connected to adjacent cells by desmosomes. They have been identified as tactile receptors. So the epithelium is joined to the underlying connective tissue by a layer called basal lamina. They are up to 300 to 400 angstrom thick and lies approximately 400 angstrom beneath the epithelial basal layer. The basal lamina consists of lamina lucida and lamina densa. Lamina lucida is composed of glycoprotein laminin and lamina densa is composed of type 4 collagen. And that brings us to the end of this video. In the next video, we'll discuss mainly about the junctional epithelium and also about some other epithelium in the aspect of Viva and MCQs. I hope you guys found this video helpful. Do like this video and subscribe to Medinare for more. Thanks for watching.